Ci siamo? Ok, hi. Okay, hello. This time I'll try to make it short, really, I promise. So, sorry, I tried to put English subtitles, closed captioning, whatever, on the last video, but unfortunately it was so long that me and my camera partner, well, we told it's easier to make another video. It's also faster, trust me. So, long story short, it was a long time since the last video, I mean the English one. Many things have happened, so I'll try to make it short. I have changed the wall X carriage and also the epsilon carriages. As you can see, the Y carriages. Now I've also changed the belts. I've removed the old ones, which were just laying over the rail. They were not constrained to the rail, so is this one, but it uses the V-wheels in a different way. It uses the V-wheels in the same way it was with the old X carriages. As you can see, is just sitting on the rail, and it's those four rails are rolling on the angles of this aluminum extrusion. Now it works, it worked nice, as you can see closer. The V-wheels are not locked on a position. They can move freely on one axis, as you can see, but as long as they go down and touch the aluminum extrusion, they don't move. So this is nice, because should the carriage bend with the weight of the whole thing here, of the X carriage, which is totally nothing for this carriage, but you know, should it rotate, they will fit in another way, but they don't. And since they are put on 45 degrees on this angle and this one too, as you can see on those edges, and they simply stay there. Now, since the belt is all the time pulling those things closer, the inner wheels are simply not used. Guess what? Only the external wheels are touching the edges. So maybe I could simplify this carriage even better just by using only the outer edge of the profile, maybe even rolling on the lower edge, but as you know, there are things on the lower part of this profile, so better not use it. Now, those carriages work really fine. The print quality overall have improved a lot. There is still something to be fixed, but well, it works. Now, I finally found the news for the open builds beam I had by side to try the things, you know, because I was arguing, oh, I should use it sometimes on the X carriage, and I finally did. Now, I did it with the wheels, of course, by rolling them on the 20mm side of the profile, and they work fine. I mean, the carriage is very stiff, it moves just a little, but usually during print it won't turn on this axis as I'm turning it now, and also this rotation doesn't happen to move at all, so it's okay. And so the only translation that occurs is along the x-axis, which is what we want, so it's okay. Now, it's still quite a little big for being just a single extrusion motor and single hot end. But as you can see, the two 40 by 40 millimeters fans, which are, you remember, Delta fans from server parts I had lying around the office, and they are very powerful. They cool everything very easily, but they are huge, so they occupy some space. Now I've also changed the radiator fan for the V6 extruder at sink, and this one cools better. Maybe I will design something else to use, I mean, by using only PLA I could keep these fans always on and divert some of the airflow to cool the radiator. It will work just the same, but maybe with this thing less, and maybe I can compact it a little bit more. Now the electronic cables, they are still the same. I will finally move the old IDC cable, which we've seen in our computer back in the times of the parallel ATA cables, with a more specific cable that I've seen from some Igus reseller we found, and maybe will be accompanied by the cable chain. Yeah, it should be more professional. This work anyway, but we'll see maybe for the more professional version of this printer. For the maker version, this IDC cable works just fine, so I think I'll keep it for the maker version. Now what else? I've changed the belts from the old black, the material name, well, you know, the standard black belts with glass fiber cable inside. Now for short distances they work just fine, they're okay, but for those long distances, I mean, this is like 3 meters long, the old black belts, they tend to get soft, they take shape, so you have to apply tension over time very often with these long belts. And with very often, I mean like once a week or twice a week. So I've changed it with steel cabled polyurethane belts. Now I've already put out some steel cable just to show you. Maybe on the white side is better. And you've seen there are 1, 2, 3, 4, 5, 6, 7 cables running along this 1 centimeter wide, also because the other one is 6 millimeter wide. And this is better with long runs, also because of the applied torque of the motor. The motor transfers its torque to the pulley only by the surface that touches the pulley. I mean, how much of the surface of the belt is touching the pulley, which of course is directly proportional with the feet and the width of the belt. As you can see, we have a 60 millimeter pulley on my right hand and now 10 millimeters, 1 centimeter, on my left hand. And as you can see, you can imagine there is a lot more surface to touch here than there. Being there more surface to touch, should you need to use 16 teeth pulleys instead of 20 teeth like this one pulley, maybe for added precision, I don't know, you could go easily, because given the more surface to touch between pulley and belt, the also more torque that you transmit to the belt, which in turn means less belt slipping on the pulley. You know, like when you apply too much pedal to your car and your wheels start running on the asphalt, same here goes when you apply too much torque and the pulley just slips on the belt. So those new belts, you can also apply less tension compared to the old black ones, because maybe the steel belts, not only because of the width, but they keep tension easily, they don't get long so fast like the old ones on these lengths. Also because, keep in mind, it's also proportional not only by the length of the belt that you are pulling, but also the tension you apply. So, keep long story short, on long distances, the wider the belt, the better. Also, the stronger the belt, the better. So, steel cable better than glass cables. Now, another thing that we are about to make it better is the Z part, the lifting part of the wall structure. One thing that we would do would be to add on the more professional part of this print. I mean, the more professional version of this printer, not this one which is the maker one. Would be adding a traditional straight steel rod, which will be very close to the trapezoidal screw, and this will be bonded, of course, together with a small part, printed part. They will be placed not as they are now, as you can see, but they will be, let's say, the geometric center between the two axes of the, let's imagine there is already a steel rod here. The axis between the two axes will be at 1/3 of the bed, and the other one will be at 2/3 of the bed. So it will be geometrically centered. I mean, there will be less distortion given by the weight, because as it is now, the weight, let's imagine it as a single point of pressure with the same load as the overall weight of the bed, centered in the middle, and such it bends the bed like this, making a torsion here on the nut, which in turn is not straight on the screw anymore. And what this does is the well-known effect, the wobbling, which really is a pain in all the prints, and even if it has been reduced a lot, is still there because the nuts are not centered. They are not in the same axis. Let's see, maybe the nut is not on this axis, but given the weight applied there on it, is just like this, just maybe a little, not that much. But being this a single principle nut, I don't know if this is the same in English, but in Italian we call them single principle. It could be multi-principle screw. It's an effect that if the nut is not perfectly in axis with the screw, it happens to wobble, and that's all. So I'll try to design this on CAD, and maybe we'll do some streaming later also with this one, and you'll see how I plan to do that. Now, of course, this will change things a little, but since I will change the carriages with the Igus ones, something that I've shown on the Italian video, let's take it, because it's easier to show than to tell. Where it is, it's there. Okay, so let's show them over there. Now, one thing, two things that we are trying. Those carriages from Igus, they are very good, and they are cheaper than roller balls ones, like for example, let me think about them. Okay, for example, these ones. Those cylindrical parts, which, sorry, I don't remember the English name, they have a lot of steel balls running along them in 3 or more rows, and they simply roll over, and they are quite noisy. Now, on a Z-axis, that's not a problem, because the lift part is only working for some, let's say, 0.2 millimeters every 6-7 minutes, I don't know, it depends on the layer time, of course. Still noisy anyway. Now think about X or Y axis, they continually move, so noise is a problem. And with those particular polymers that Igus developed, they simply run on aluminum. In this case, they could also go on steel easily. I mean, with the proper polymer, I don't think it's the same, because they have many. And the sound that they produce is really something almost unhearable. Now, the fun part is that you could, in theory, we are trying to, print yourself the same parts you see here, maybe adjust because it's a 3D printed pad after all, the diameter inside by just those plastic little parts and the extrusion, and do yourself the carriage. Now you don't have to do this carriage the same, you could just build a carriage like this one, and instead of the wheels put on those little parts. So you just draw the cylindrical holes and put inside those little yellow parts, and you're done. Now it's something you could do, because this aluminum part is very heavy and is not something good for a 3D printer, which has to be the lightest possible, always because of backlash, and unless you want to have a jerk speed maximum of 6-7, well, you'd better lower the weight. Now this kind of rail, I'd like to use it, place it this way, replacing the V-slot beam we have here, and on the Y-axis I'd like to use always Igus sliders, but not those because they are quite large. I've seen the compact rails which are already in use in many Delta printers. I'd like to use one here. So to make a very, very small Y, and also 3D printed, of course, carriage which just will hold this beam, and of course will catch the belt on the side. It will be moved, of course, so this will all change, but you'll see on the CAD. Now last but not least, we will assemble a carriage Z, because all the wobbling comes out because of the Z screws. So since we're trying to make the more efficient printer possible, I mean on the cost side, if you don't have to go this big for a printer, but maybe you just could go for alpha meter, you could go theoretically with those kinds of belts which are very, very strong. You could theoretically remove the screw and move the bed with the belt, with a belt driving seat, like a carriage Z. And of course keep the Y-axis on whatever you want, I mean on the belt, I mean on the drive, on the you could move the chassis, you could move the bed. The easiest way, of course, is just keep it up and simple, like a Prusa i3 printer. I mean, with the belt moving this way, instead of having trapezoidal screws or bars like this one, you just pull the motor, you turn it 90 degrees and have some sort of belt running along. You could also make it H-bot if you want, as long as it's small. Otherwise, try to go carriage Z. And then you're set. Now it's something that we have already ready on the CAD, on the computer, but still we have to take the parts to build it. But as soon as we have the parts, maybe we'll make a video of us assembling it. So I hope you've enjoyed it. If you have any ideas of something we should tell, just ask on the comments, whatever, drop us an email. We are always very happy when you write something under the video, so please do it. Thumbs up, thumbs down if you don't like it, and suggestion always welcome. So till next time, bye bye.